Real quick review for tomorrow, because I'm not doing a whole day review. There's no review packet. There's nothing on Classroom to review for tomorrow. Just I want to keep you heads up. There will be Hills and Sass on there tomorrow. And when we're done with the notes, I'm probably going to forget because I get too intense and out of control. Remind me to pass back your quizzes, please. All right, remind me to do that after we're done with today's notes. Hills and Sass, one question review. All right, one question to review. Anything we've talked about, sine, cosine, tangent. All right, some things that come to mind: elevation versus depression. Make sure we know where those angles are and how to make those angles on a triangle, because those vocabulary terms will come up tomorrow. Find an angle. That's what your homework was on, and I'll just put in parentheses: sine to the -1, cosine -1, tangent -1. Find a side. And then I'll put Pythag on there. Notice what's not on here: 30, 60, 90, 45, 45. I didn't put any on there. So if you find yourself using that tomorrow, you might want to stop and just check yourself, because things aren't probably going right. All right, it's probably not a good day if you're using those tomorrow. All right. I think that's it. All right. So all good. Oh, and what we do today in class. Okay, what we do today in class will be on there as well. Questions, comments? Okay, let's do this then, because this shouldn't take too long here today, but it's still a tricky topic to pick up. All right, I didn't put numbers on my sides. I put X, Y, and Z. And what I'd like you to do right now by yourself to see if you can do it, using X, Y, and Z, what's sine of A equal to? The sine of angle A is equal to what ratio? Using X, Y, and Z. Okay, using X, Y, and Z, what's the sine of A equal to? Without using letters, just from using SOHCAHTOA, what is sine equal to? Just by using SOHCAHTOA, what sides do you use in the sine ratio? Let's go. Whoa. Uh-oh, suspense is killing us right now. Wow. I don't know how long the suspense is going to kill me here for, because I'm getting impatient. Like that would have helped. Oh, there we go. 2. What's your sine in general equal to, Matt? Opposite over hypotenuse. Good. Now using your letters, what is opposite and hypotenuse for A? Okay, 16. What's opposite? Y over Z. There you go. So Y over Z is my sine ratio. Now a little challenge for you, honors kids. Find me another. It says what other trigonomic function that's sine, cosine, tangent. So find another one, sine, cosine, tangent, coming from an angle that's also equal to Y over Z. Okay, so find another one that's equal to Y over Z using sine, cosine, tangent, and an angle again. All right, if you want to discuss it in your groups, fine. If you want to try it by yourself, that's fine. Give me another one that's also equal to Y over Z. All right, what do you got? You got another ratio that's equal to that? Okay, this is 18.
Not here.
No problem. 16. Good job. Cosine C is equal to y over z. Nice work, nice work, nice work. All right, so let's build upon this. We notice that, ready? We notice that the sine of A is equal to the cosine of C. We all agree with that? Sine of A and the cosine of C, they're both y over z. Now I want you to take it a step further. What do I know about angle A and angle C on that diagram? Anybody think they can come up with a conclusion for me? What do I know about A and C? Angles A and C. And don't get too crazy on me. All right, all of you can realize what A and C, what type of relationship they have. Paul, you think you're going to take this?
Complementary angles.
Are they?
Yes.
What's complementary mean again? Refresh our memory.
They add up to 90 degrees.
Do A and C add up to 90? Everyone agrees there? Yeah, nice job, Paul. What's so special about them? They are complementary. Good work. And here's the big note for today. If two angles are complementary, if two angles add to 90, and we'll write this down in a second. If two angles add to 90, the sine of one is equal to the cosine of the other. Watch real quick, and you don't have to write anything down. This is going to be the easiest question I ask all day. There you go, Meg. Just give me an angle less than 90, Meg.
40.
Okay, thanks. 40. The sine of 40 degrees. Do it on your calculator. Go ahead. I'll do it with you. Sine of 40. You get this crazy looking decimal, right? Sine of 40, right? 0.64. Everyone's getting that? Give me another one that would also come out to be 0.647, da-da-da. Well, what did we just learn? If two angles are complementary, the sine of one equals the cosine of the other. So sine of 40 is going to have the same decimal value as what? Cosine of, oh my, did I just hear a 60 in there? Cosine of 50. Try it out. There you go. So if two angles are complementary, the sine of one equals the cosine of the other. One more time. Just make sure we're all good on this demonstration. 22. Give me another angle less than 90. 22. Cosine of 22 will be the exact same decimal value as, what do we predict? Uh-oh. You gave him a tough one, Quan. I got to do
68.
sine of, oh boy. I got a 68 and a 78 right now. What do I got?
68.
All right, see how this works? All right, the sine of one equals the cosine of the other angle as long as I know what about the angles? They have to be complementary. If I just do this, sine of 10 equals cosine of 30, that's not going to be equal. All right, the angles must be complementary. And the big vocabulary word of the day here is sine and cosine are what we call cofunctions of each other. Cofunctions. And here's, ready? Watch how cool this is going to be. What's the full name for this? What's the full name for this?
Sine.
One more time.
Sine. Cosine.
Let's do that again. What's the full name for this one?
Sine.
Sine, cosine. Cofunctions, yes. All right, everything has a pair, like tangent has a pair with it, but you guys get into that next year in Algebra 2. We only stick with sine and cosine or cofunctions, meaning they're equal when their angles add to? When their angles add to? 90. All right, so let's officially write this in the conclusion box now. We've talked about it enough. If angle A, and I'll just use B now instead of C, if angle A and angle B are complementary, the sine of A, one job, is going to be equal to what? If A and B are complementary, they add to 90. The sine of A is going to have the same value as cosine B. Again, I'll stress it one more time. This is only true if your angles add to 90. Okay, if your angles add to 90. You ready to try this out? Do a couple problems together and then go over the quiz, and you got the rest of the time for homework. All right, let's do it. Express the following as equivalent trig. Again, when it says equivalent trig functions, that's sine, cosine, tangent. So give me another value that's the same as cosine of 20. Okay, give me another value in another degree that will be the exact same decimal as the cosine of 20. Cosine of 20, and what else will have the same value? 3? Sine of 70. Good. Angles have to add up to 90. And I'm never going to introduce tangent. It's always sine and cosine go together. Sine and cosine. How about the sine of 37? What else is equal to the sine of 37? 7? Is that a question or an answer? Answer. Sine of 50. Sine? Cosine. No issues yet, right? All right, here you go. I got angle x and I have angle x plus 20. They're both acute. And I'm told that the sine of angle x is equal to the cosine of angle x plus 20. Find x. If you are setting them equal to each other right now, I have not done a good enough job with this yet, because that's not true. What I have up on the board, not true at all. What are they telling me? Look at what they're telling you. Sine and cosine are both equal. That only happens one time. When what do I know about the angles if sine and cosine are equal? Those two angles are equal. They have to what? Add up to 90 degrees. If you see sine and cosine are equal, oh, that must mean their angles are complementary. So x, not equal to, but plus the other angle, x plus 20, equals a 90 spot. Okay? Again, sine and cosine only equal if the angles add to 90. Cofunctions. So go ahead and solve this beast. 2x equals 90. X equals, why 90? How about 70? I'm getting rattled. 35. Questions, comments, concerns? Ready for it. All right, do we really know what's going on now? Let's figure it out. Triangle ABC sees the right angle. And here, just let me discuss real quick why you're getting that information. If C is the right angle, what do you guys know about the other two, A and B? They're complementary. They add to 90. That's why I'm giving you this information. C is the right angle. The other two have to add to 90. So if cosine of A is radical 21 over 5, what's the value of sine of B? I don't want you to overthink it. What do you know about A and B again? They're complementary. So if they add to 90, the cosine of one angle is equal to the sine of the other. And I know some of you guys don't think it's that easy, but yes, it is here. A and B are complementary. Cosine of A is the same as the sine of B. So what's my sine of B? Radical 21 over. Yeah, that's it. You guys would have wrote this down. Cosine A equals sine B. Okay, cosine A, radical 21 over 5. It's got to match on the other side. Radical 21 over 5. All right, I don't want to do them all with you, so you can work in your group or on your own on the next three. Okay, work in your group or on your own on the next three here to finish it off. I'll give you plenty of time. Go ahead and we'll go over them as a group. And while you're doing that, actually, no, I won't hand them back yet. So is 5/13 for number 5 here. Whoo, talk to me here. Talk to me. 8, what do we think for this one? Cosine of B equals 5/13. So does. Do I have an 8 anymore? No? No 8?
Oh, yeah.
Hi, Charlotte. How are you? Good to see you.
Um,
Cosine of B is 5/13. What also equals 5/13?
Sine of A.
Sine of A. They're equal to each other. They're equal. If they're complementary, they're equal. Hopefully we didn't set these equal to each other here. Hopefully not. Okay, because if I'm sine and cosine are equal, the angles aren't equal. I guess they could be if they're both 45, right? But they at least add to 90. They at least add to 90. So what was our value of x on this one? Oh, 9. 25. Good work. 25. And finally, I got a right triangle. Again, I'm telling you the right angles at C, so you guys know A and B are complementary. All right, so A and B are complementary. So if sine goes up, sine of A increases. What happens to cosine of B? 19, talk to me.
It also increases.
Darn right. Why? Because they're already what? Okay. They're equal, right? Sine of A in this problem is the same as the cosine of B. So if A increases, so does cosine B. If I could spell that. Increase is a good reason because they're equal. One goes up, the other goes up. All right. Questions from you guys? All right, let me get back your quizzes because I know there might be a few questions on your quiz that I can go over right now. Let's see. Let me get the quiz up here first. Again, this quiz counted towards the second quarter, so tomorrow's quiz will be the first grade of the third quarter. No. PDFs, quiz number. Oh, you'd like me to open quiz 2, wouldn't you? Remember that one? Oh, geez, remember that bloodbath number 3? Cheers, Meg. Mahmood. Rip. Okay, now that we've got it back, you're looking at it, you knew you made a mistake anyway. Anybody want to see any one in particular up here? Go ahead, Eva, what's up? Number 6, yes I can. We got the equilateral triangle. I'll put it over here so I got room to work. And the altitude has a length of 33 feet. Altitudes form right angles, so that's why I'm allowed to put a right angle symbol there. It's 33 feet. Find the perimeter. All right, so because this is equilateral, all angles are congruent, which means I can confidently put that that angle is 60, which makes this now into a 30, 60, 90 triangle on the left. Okay, with me so far? The 33 is across from the 60, which makes it the longer leg. So my rule is the longer leg is equal to the shorter leg times radical 3. Let me plug in 33 for the longer leg. Shorter leg times radical 3. If I want to get the radical 3 out of there, I divide it. So the shorter leg will be equal to 33 divided by the square root of 3, but we talked, can't have a radical in the denominator. So to get rid of it, I multiply top and bottom by radical 3. So keep grinding away here. Shorter leg, 33 radical 3. Sorry. 33 radical 3 over 3. Still reduce. Still reduce. Up here, shorter leg is equal to 11 radical 3. So across from the 30, 11 radical 3. I'd like to know what the hypotenuse is because that's a full side of my equilateral triangle I'm trying to find the perimeter of. So now I go to the hypotenuse rule. 2 times shorter leg. 2 times 11 radical 3. So the hypotenuse is 22 radical 3. One side is 22 radical 3, meaning all 3 sides are 22 radical 3. And if you add those up, 22 radical 3 plus another 22 radical 3 plus another 22 radical 3, add up the 22s and you get 66 radical 3 for your perimeter. All right, that was a pretty involved one. That's why it was probably 5 points. So. Anything else we want to touch upon? Let me know. Hill SAS tomorrow and Pythag. No 30, 60, 45, 45. Hill SAS, though. Get ready. All right, get ready for that question. Nothing else? Okay, keep grinding away. You still got 10 minutes. Keep going on your homework. I did throw a couple different questions on there for homework, but it's not a review, that's for sure. That's going to be on you guys.